We will discuss our next chapter as per our syllabus. Just a minute. Yes. So far we have discussed vectors, then motion in straight line, then motion in a plane. Three things. Next is we will discuss laws of motion, Newton's laws of motion. Our next chapter, Newton's laws of motion. And this is, I think, our chapter number 4. Chapter number 4. Okay. And if you recall, if you remember, while discussing the basic introduction to physics, I told you there are several branches in physics. Physics is fundamentally a study of relation or a study of interaction between matter and energy. And we study this interaction in different situations and give different titles to each kind of interaction, or we call them as branches of physics. There are several branches in physics, like there is optics, there is electricity, there is sound, magnetism, modern physics, geophysics, astrophysics, biophysics, nuclear physics. Different branches are there. Out of all these branches, one of the oldest and one of the most significant branch is mechanics. Mechanics. One of the most significant branches in physics is mechanics. What do we study in mechanics? While we started this motion in straight line, I told you that we are studying now kinematics, then we will study dynamics. I gave 2, 3 terms: kinematics, dynamics, and statics. These kinematics, dynamics, and statics, they are the branches of sub branches of mechanics. Kinematics, dynamics, and statics are the sub branches of mechanics. Overall, what is mechanics? It is the study of motion of bodies. It is the study of motion of bodies. And we divide this study into 3 subparts: kinematics, where we don't consider the cause of motion; dynamics, where we consider the cause of motion; and statics, a study of bodies which are in equilibrium under the action of forces. Okay, so now we can say that we have completed kinematics part, motion in straight line and motion. These two together come under kinematics, because we only studied where will the body be, how much distance or displacement will it cover, how fast it will be moving, or how much time it takes. But we did not consider what made the body to move. We did not consider cause of motion in the previous 2 chapters. Now here we will study motion along with its cause. Motion, study of motion along with its cause is dynamics. Another name for dynamics is Newton's laws of motion. Okay. So say dynamics. It is the study of motion of bodies considering the cause of motion. Considering the cause of. Okay, right. Then in this part, the first thing, the major portion of this chapter, Newton's laws of motion, as the name itself says, is we have to study three laws of motion. Newton, everyone knows Newton. He discovered gravity, and he proposed a law to measure the gravitational force, and he has a lot of contribution towards mechanics. Newton has done a lot of work in optics also, in heat region also. So influence of Newton is very much on physics. So that's why we call Newton as father of physics, because he has contributed a lot of things to the field of physics, and he
In
a lot
calculus.
of contributions in the field of mathematics also. Calculus was invented by Newton. Calculus, the differentiation rate, all these things that we studied, it was invented by Newton. Okay, so first of all, we will try to understand the three laws of motion proposed by Newton. Newton's laws of motion. Three laws are there. We will study them one by one in detail. You should understand these things very, very clearly. I, to be correct, your actual physics starts from here. Actual physics starts from laws of motion. Once you understand what is force and what are the effects of a force, from there your real physics starts. All the things that we studied till now, vectors or basic mathematics or motion in straight line or motion in plane, all these things, they are like fundamentals, ABCs to know physics. Real physics starts from here, dynamics. Okay. So first law, before understanding first law, you should know something called inertia. Because first law, Newton's first law is based on this concept of inertia. What is inertia? See, simple situation, if I have a body placed on a surface and I leave it like it will be there unless and until someone or something moves it. Or in the same way, if a body is in motion, let us say it is moving with some constant velocity v, if nobody tries to stop it, nobody or nothing, no agent, no external agent tries to stop it, it will continue its state of uniform motion. A body which is at rest will continue to be at rest, and a body which is in motion will continue to be in motion unless some external agent or some external body tries to change its state of motion. Or in other words, the same thing can be said in other words, like a body which is at rest cannot come into motion on its own, and a body which is in motion cannot come to rest on its own. These are the two things. Okay. Now, the what is happening here? A body which is at rest. If you take first situation, a body which is at rest cannot come into motion on its own. That means it cannot move on its own. That means it cannot change its state of rest on its own. Here, a body which is in motion cannot stop on its own, or a body which is in motion cannot change its state of uniform motion on its own. That means this body, not only this body, any body in the universe, any body is unable to change its state of rest or of uniform motion. We call this inability of a body, due to which it cannot change its state of rest or of uniform motion on its own, as inertia. So inertia is It is the inability of a body. Inability means something which a body cannot do. Normally, we define things like what a body can do, but this is a special term, special property of a body, which is being defined as something which a body cannot do. Inability, something which a body cannot do, not something which a body can do. Okay, so it is the inability of a body to change its state of rest or of uniform motion. State of rest or of uniform motion on its own. This simple thing is inertia. Inertia. And on what factor does this inertia depend? Inertia depends on mass of the body. Mass is the measure of inertia. Greater the mass, greater the inertia. So we can measure inertia in terms of mass of the body. Okay, this is inertia. Now using this concept of inertia, Newton defines his first law as
Sir,
uh,
sir, how can inertia vary in objects, sir? Any object cannot come into motion or rest on its own. So every object will have inertia,
but
sir.
how much effort you need to put in to move that particular body will be different. It depends on mass of the body. There is a
Oh,
bicycle. You want to move that bicycle, you need to apply a bit of effort. There is a car. If you want to move that car, you
yes,
need
sir.
to apply more effort.
Okay, sir.
Let us say, and there is a very common misunderstanding or misconception regarding this inertia in most of the students. That is, most of you think that inertia, due to inertia, your body cannot move. Due to inertia, body cannot move. That is okay, that is correct, but that's not the complete thing. It's only half of the thing. Due to inertia, a body cannot stop also. That's also inertia. Inertia is not only the inability of a body to move on its own, it is also inability of a body to stop on its own. To understand this, take a simple situation. Let us say I have two balls, A and B. Both are identical. Identical balls, same. Everything is same. Let us say I push them or I roll them on a horizontal floor. Yes, to understand with the same effort or with same force. Then A rolls along the floor and stops here. B also rolls, stops here. Let us say A covers a distance of 2 meter and stops. B covers a distance of 4 meter and stops. Now if I ask you, which body has more inertia,
B,
A
sir.
or B?
B,
Why?
sir, we have to put more effort to stop,
A,
sir.
no, you are just
Sorry, sir.
rolling it
Yes,
and
sir.
leaving. You are not doing anything.
Yes, sir.
Why?
Sir, because A
Because
is
it
less distance than B, and so we put more effort.
Effort is same, balls are same, everything is same. To understand simply, you roll ball A,
Yes,
travels 2
sir.
meter, stops. You roll ball to B, travels 4 meter and stops.
sir A is heavier.
Yes,
A
sir.
is heavier, sir.
In inertia, I'm asking which ball has more inertia.
Sir, A,
Yes,
sir.
sir.
A.
Yes,
Yes,
sir.
sir.
Why?
Because its mass is high is more
I
than B,
told
sir.
you,
That's why
I told you
considered only as B.
both are identical balls. You forget other things, how much force you are applying, what is the size, the shape, color of all these balls. Both are identical balls. Both are given the same effort, given the same force. But we see that A travels 2 meters and B travels 4 meters and stops.
Sir, we applied both effort now, sir. Therefore, A went little distance, sir. B went far distance, sir.
So,
So the inertia of A is more than inertia of B, sir.
what is inertia?
Inability of a body to change its rest or
Ability
motion.
of a body to change its state.
Yes,
What is
sir.
the state of motion of A and B? They are moving with uniform speed,
Velocity.
some
Yeah,
u.
speed.
Uh, who is unable to change the state, A or B?
Yes, sir.
Yes, sir.
B was unable to change its state. It could not stop. B was unable to change its state of uniform motion easily. It took longer for B to change its state. So whose inability is more, A or B?
Yes, sir.
A's ability is more. A can quickly come from motion to rest because it is stopping at 2 meter only. But B is not able to do that. B is not able to do that. It is not able to change its state of uniform motion to state of rest. It took longer for B to do that. That means, is B able or unable?
B, sir.
B is
Unable, sir. It's unable to stop itself.
unable. So, which has more inertia, A or B?
B, sir.
B has more inertia because inertia is measure of inability of a body. Something which a body cannot do. That's why I told you it is measure of a body, something which cannot do, which it cannot do, not which it can do. A can do that easily. So its inability is less. That means its inertia is less. B B's inability is more. So its inertia is more. That's why what happened here with you is you thought that A is stopping quickly. Stopping quickly means it is coming to rest. Coming to rest means that is inertia. That's why I told it's only half part. The same thing applies to a moving body also. If a body at rest cannot move, that is due to inertia. Okay. But if a body which is moving cannot stop, that is also inertia. Don't think that bodies which are at rest only will have inertia. Bodies in motion also have inertia. That due to that inertia, they continue to be in that state. They continue to be in that state. Okay. And inertia is of three types. Types of inertia. Number one, inertia of rest. Inertia of rest. What is this? Inertia of rest. It is the inability of a body to change its state of rest on its own. It is the inability of a body to change its state of rest on its own. Simply, if a body is at rest, it cannot move on its own. Some external agent need to move it. So the inability of a body due to which it cannot move on its own is inertia of rest. If we take a simple example, suppose you are standing in a bus. You are standing in a bus. The driver starts the bus suddenly in this direction. The driver starts the bus suddenly. Then what happens to you?
We fall backwards, sir.
You fall backward. You fall in the direction opposite to the direction of motion of bus. This is because of your inertia of rest. Your body was at rest, and due to inertia of rest, it continues or it tends. It wants to be in rest only. It does not want to move because of inertia of rest. But the bus moved, and your feet, which were in contact with the bus, they moved, but your body does not want to move. So as a result, you fall back. You fall back. This is inertia of rest.
While
A
the bus
standing,
takes turn, also the same happens, no, sir.
I will come to that. A standing passenger, a passenger standing in a stationary bus. A passenger standing in a stationary bus falls back when the bus starts suddenly. Starts suddenly. Okay. Second type of inertia is inertia of motion. Inertia of motion. What is it? As the name itself says, it is the inability of a body it is the inability of
Sir,
a,
in the given example, what is it? Says stationary bus falls.
a passenger standing in a stationary bus falls back when the bus starts running.
Okay.
Inertia of motion, it is the inability of a body to change
Its state of motion on its own.
its state of motion on its own. You can again take the same example of a bus and passenger, but this time the bus is moving. The bus is in motion. It is moving with some constant speed. You are standing in the bus, and the driver he stops the bus suddenly, applies brakes, sudden brake. Then what happens to you?
We fall front, sir.
You fall forward. That is because of inertia of motion. Your body was in a state of motion, and it does not want to change because of inertia. It wants to continue in the state of motion. But as the bus stops, your body tries to continue in the same direction, same state of motion. So you fall forward. A passenger standing in a moving bus falls forward when brakes are applied suddenly. This is inertia of motion. Third one, inertia of direction. What is this inertia? It is the inability of a body
To change direction on its own.
of a body to change its direction of motion on its own. Again, you can take example of a bus.
Sir,
Let's
once can
say
we scroll up?
a bus is moving with constant speed. Let us say, and you are again standing in the bus or sitting some whatever. If the driver takes a left turn suddenly, what happens to you?
We fall right, sir.
You fall towards right. If the driver takes right turn, you fall towards left. Reason for this is when the bus was moving in a straight line, your body was also moving in the same direction, and your body has got this inertia of direction due to which it wants, it tends, it wishes to move in the same direction. It does not want any changes. It does not want to change anything. But as a bus takes a sudden sharp turn, left or right, your body tries to continue in the same direction, as a result of which you feel that you are falling towards left or right. But in reality, bus is taking a turn and your body is trying to go straight. The result of this is you feel that you are falling out or falling in. A passenger in a bus falls sideways. Falls sideways.
Sir,
Yes, when the bus takes.
sir, that means our body is in same position, but the bus moved.
Yes.
Okay, sir.
When the bus takes sudden turn. Okay, these are the three types of inertia: rest, motion, direction.
Sir, but the direction is also opposite, no, sir. If the bus moves right, we will fall into a left.
That's what I was telling. Your body does not fall in the opposite direction. Practically, what happens is bus takes the turn, and you try to go in straight line. The effect of it is you feel that you are falling towards right. It is not like your body tries to go in the direction opposite to the direction in which the bus takes turn. It's not like that. Your body wants to go straight, but the bus is taking turn. Effect of it will be you feel that you are going towards right.
Okay, sir.
Right, and this inertia, it is a property of not only non-living things like some table, some chair, some block, some object, some non-living thing. It's also a nature of living things also. Even we have inertia. We have inertia. Like say, suppose you are, this is winter is going on, you are sleeping, and your parents want you to get up early in the morning, 5:30. Will you feel like waking up? No, because your body is in a state of inertia. What is that inertia? You were in a state of sleep and you want to continue that state of sleep. You don't want to change that. You don't want to come out of that state. So you don't feel like getting up. You have to overcome that inertia. And suppose you are playing and your parents call you to sit down and study. You don't like stopping to play and coming down to study because you want to continue that state of playing. That is also inertia. So whatever a body does, if it wants to continue doing the same thing, that is inertia. And ours is psychological inertia because all these things that whether you want to do something or not, it depends on your state of mind. And for non-living things, it is
Physical
physical.
inertia.
Okay, right. Next, based on this inertia, Newton gave first law. First law, or this is also called
Law of
law of
inertia.
inertia. So what Newton says here is every body continues to be in its state of rest or of uniform motion unless acted upon by an external force. This is the statement of Newton's first law of motion. Every body continues to be in its state of rest or of uniform motion unless acted upon by an external force. So here Newton is using the word force, the term force. He introduced this term force in his first law. Okay. Right, simple law. If a body is at rest, it will continue to be at rest. It cannot move. If a body is moving, it will continue to move. It cannot stop until an external force acts on it. If this body, this block is at rest, if you leave it like that, it will be there till eternity. If you don't do anything to it. Okay. But if you apply a force on this, it will move. It will change its state from rest to motion. Similarly, a body which is in motion, which is moving with some constant speed v, it will continue to move until eternity if nothing changes it. No external force acts on it. But due to friction or air resistance or some other damping force, this body will eventually stop. So if you slide a box on ground, it will slide for a certain distance and stops. Reason for it to stop is the friction between it and ground. Suppose you do the same thing in space. You go to outer space and you push the same box. The box will try to go. It will be going on forever. It will not stop. Because there is no external force, there is no external agent which is trying to change its state of motion. That's why we have this statement. Every body continues to be in state of rest or of uniform motion unless acted upon by an external force. Okay. So Newton gave us here the concept of force, which is the foundation of this chapter. This entire chapter is based on force. Okay. So how can we understand force? What is a force? In your lower classes, you might have got the description or definition of a force as it is a push or pull acting on a body. Okay, that's fine. Push or pull acting on a body is force, but that's up to, you can say, elementary level. But in your high school level or when you go to +2 level, that definition is not sufficient. You should understand force in a more technical and more comprehensive way. What is the definition? So from first law, if you observe, Newton is saying that if a body which is at rest has to move, force should act on it. And if a body which is moving has to stop, force should act on it. That means force is something which can move a body or which can stop a body. That means force is something which can change the state of motion of a body. Force is something which can change the state of motion of a body. So force is defined as it is a physical quantity which can change the state of motion or state of rest, which can change the state of rest or of uniform motion of a body. So anything which can change the state of rest of a body or state of its uniform motion, you call it as a force. And based on this, we can further understand force with some more details, like what can a force do to your body? A force can bring a body to motion from rest. The body is at rest, you apply force on it, it moves. So force is something which can bring a body to motion from rest. Then also force can bring a body to rest from motion. If a car is moving, you apply brakes, it stops. So brakes produce friction. Friction is a force, and this force is making the car, the body, to come to rest from motion. Then another thing is force can change the direction of motion of a body. Direction of motion of a body. Suppose a body is going in this direction. You apply a force in this direction. What happens? It changes its direction. Again, you apply a force like this. It again changes its direction. So force is something which can also bring change in direction of motion of a body. Another thing which a force can do is force can deform a body. Force can deform a body. Deform is changing the size, shape, or structure of a body. This is deformation. Suppose you take a soft body like a rubber ball or a sponge or your duster, and you apply force on it. You try to crush it in your hand. Its size, shape will change. Of course, you can do this with soft bodies. For hard bodies, you need to apply larger force. Suppose you have a stone, you cannot change the size or shape of the stone with your hand. If you put it under a stone crusher, it will break down or it will change its shape, something will happen. So force can deform, it can change the size, shape, or structure of a body. That's another effect of force. So force can do these four things fundamentally: motion to rest, rest to motion, change in direction, and changing the or causing deformation in a body. This is force. Okay. So Newton's first law gives us the definition of force. From Newton's first law, we get the definition of force. What is the definition? This is the definition. Okay, this is first law. Second law, Newton's second law. But before going to Newton's second law, you should know something called momentum.
Sir,
Yes.
sir, we can say that Earth has inertia.
Earth has inertia. Yes, it has inertia. Because of that inertia only, it is moving continuously without stopping. Momentum is the next thing. Momentum is the next concept we should understand to understand Newton's second law. What is this momentum? Suppose a body is moving, a body of mass m is moving with some velocity v in this direction. Is moving in this direction with velocity v. Now it is in motion. Moving means it is in motion. It is in state of motion. Okay. If you want to understand how much motion the body has, like suppose if I want to describe the size of a body, I can tell it in terms of its mass or volume. Okay, suppose I tell you that one body has 2 kg mass, another body has 20 kg mass. Then if you want to understand how much matter is contained in a body, then you measure its mass. Greater the mass, greater the matter contained in that body. Similarly, if a body is moving, it is in motion, and you want to measure how much motion the body has, then you go to momentum. Then you measure its momentum. How we define this momentum is, it is the product of
Mass and velocity, sir.
mass and velocity of a body. Product of mass and velocity is momentum. That means momentum and don't get confused with this spelling of momentum. Some students write it and read it as momentum. Momentum. There is no V there. Movement is different. Moment is different. It is wrong. It is moment. So momentum is defined as the product of mass and velocity. And the symbols that we use, standard symbols to represent momentum, is P, small p, not capital, is equal to m into v. M mass, v velocity. So it is denoted by P, mass into velocity. Okay. What should be its unit? SI unit of momentum is mass into velocity. Mass is measured in kg. Velocity is measured in meter per second. So kg meter per second is the unit of momentum. And it is a vector quantity. Momentum is a vector quantity. That means it has direction. What will be the direction of momentum? Direction of momentum is along the direction of velocity of the body. Direction of momentum is along the direction of velocity. If the body is
Sir,
moving
kg multiplied by meter per second, sir.
there are no multiplication, addition, division on units. They are combination. That's all. Kg meter per second. It is. You should not read it like kg multiplied by mass multiplied by meter divided by second. It's not like that.
No, sir.
Kg
What
meter
is the
per
function between them?
Okay, it's not even product. It's just a combination. That's all.
Sir,
Oh.
so like momentum is a product of mass and velocity. What exactly is its definition, sir? Like what does it do? What is it, sir?
It is a measure of motion contained in a body.
Sir, how can a motion be contained, sir? Because motion means only movement, no, sir.
It is a measure of motion contained in a body or measure of motion possessed by a body. You can write it whatever. The concept is, meaning is that it is the measure of motion contained or possessed by a body. Greater the momentum, greater will be the motion, or larger the motion that a body has. How much motion, or how with what amount of motion a body is moving, that is represented by momentum. So here you can see momentum is directly proportional to mass. Greater the mass, greater the momentum. And momentum is directly proportional to velocity. Greater the velocity, greater the momentum. Okay, this is momentum. Based on this, we get second law, but there are some more details of momentum that we should know. We'll continue this tomorrow.
Bye, sir. Thank you, sir. Good night, sir.
Thank you, sir. Bye, sir. Good night, sir.
Thank you, sir. Bye, sir. Good night, sir.
Good night.